What was biology's dark matter moment, or what should have been, according to author Philip Ball? I'll try and explain succinctly and hopefully not get too much wrong. I told you that for this second channel I was thinking of trying to summarize just interesting things I read or come across. So I'm reading a book that's been on my list for a little while, How Life Works by Philip Ball, who's a fantastic science writer, and I strongly recommend you check out some of his work. And this is just, you know, I'm not actually that far into the book, but I got overexcited and I wanted to share with you. There has already been so many moments of kind of, you know, wow. And one was where he draws this parallel to the discovery of dark matter. And he says that in biology, we have made some discoveries which should have led us to completely change our model of how we understand life, in the same way that physicists completely changed their understanding of the universe after the discovery of data that suggested the existence of dark matter. He said what didn't happen then is that physicists turned around and said, well, this doesn't change anything, but he suggests that that's what has happened in biology, that actually biologists have said that you know, they haven't updated their paradigm. And so there are two discoveries as I understand, and the first is from the days of the Human Genome Project, that prior to that, if you had asked most people in the know how many genes we had as humans, they would have guessed about 80 to 100,000. That was the typical estimate. And actually what came back was about 24,000 genes, or I think now some people feel it maybe even less than that, which was a way smaller number than anyone was expecting. And if you consider that organisms, like, I can't remember which ones, but like onions or something have more genes than that, that should have been the first clue that it isn't just as straightforward as genes coding for proteins. And this is the reason I'm interested in it, because he said that the idea that genes are just these protein coding things and these are the building blocks of life is way too simplistic. And you shouldn't think of DNA the way it's normally described as a blueprint or a set of instructions, because that's not what it is at all. And this is, he doesn't talk about this specific thing, but of interest to me, because, you know, something I talk about frequently is the kind of mechanistic bias that a lot of people have, particularly in the kind of biotech, tech bro, wellness, biohacking world, where people, you know, sell this idea that you can just sequence your DNA and get these untold insights. There is I don't know what that is, a hornet or an enormous moth. It's huge. Oh my God, I hope it doesn't come this way. I think it's a hornet. It's like black and yellow stripe. Oh God, there's like a nest in the roof. Well, thankfully this is my mother-in-law's house, not mine. The death hornet wasp distracted me there, but what I was trying to say is that complexity doesn't seem to correlate to the number of genes, because even though, you know, Shrek is complex with layers like an onion, I think it's fair to say that onions are less complex than humans, and yet they have more genetic material. So there are lots of other examples of this. So it should have been our first clue that the number of genes doesn't seem to correlate to complexity, and something else is going on. Now, don't ask me which has more genes, a wasp or Shrek, because I don't know. But if you like, I am willing to make it up and just sound confident. And the second discovery that he said is the existence of what's called non-coding DNA, and he kind of says that in itself kind of betrays a bit of bias, that we from the beginning thought that the DNA that doesn't account for protein coding structures was deemed non-coding, i.e., you know, thought to be just useless or unclear what its use was. And that initially, that, you know, we didn't find that many, but then over the years, in the 20 years or so since the Human Genome Project came out, the number of non-coding DNA sequences massively outnumbers coding sequences now. And it was thought that if they don't code for proteins, you know, what do they do? And it turns out that the end product is the RNA. That is, I'm really scared. You don't understand how big this thing is. Whoa. And so with these two discoveries, we should have updated our way of thinking about DNA, that it is far more complex in the way that, oh, a huge bat. I guess you tuned in thinking this was going to be about DNA, but actually we're watching biology in action. That is the wonder of recording from a rooftop in India. So just as dark matter greatly exceeds normal matter in the universe, non-coding DNA exceeds protein-coding DNA, and in fact the RNA it encodes is the end product, performing vital functions. A favorite example of mine is the clock genes, which I'll try to do a video on sometime. And Ball's point is that unlike cosmology, biology hasn't undergone the same overhaul of our model, with major organizations like the National Human Genome Research Institute still referring to DNA as a blueprint instead of kind of focusing on these regulatory aspects. Anyway, here's a bit of relaxing rain in South India to finish the video.